Today we're going to look at medians and altitudes, their properties, and how we can use that to solve problems. So to start, a median of a triangle is a segment from a vertex to the midpoint of the opposite side. So those are our key components. It's got to connect a vertex to a midpoint. A centroid is the point of concurrency where all of the medians will meet. This is always, always, always inside the triangle, and it's also the center of gravity for this triangle, meaning if we were to try to balance this structure as if it were a building, we would need to make sure that most of our supports were at this centroid right here, since that's where a majority of the gravity is going to fall. So, with that, this point of concurrency, this centroid, has the strangest rule that we've learned so far. And I'm going to kind of show you a way to make this a little bit easier to break down. However, make sure that you write down this component here at the bottom. From the vertex to the centroid, so from here to here, or from C to P or A to P, is 2/3 of the length of the entire segment from B to F. The midpoint to the centroid is 1/3 the length of the entire median. Now, if we think about that, what that really means is that this part is 2 times as large as the other part of the segment. So when we can, we're going to look at it in terms of 2 parts and 1 part instead of thinking about it in thirds. So in the diagram here, we know that x to A is 8. So that's the vertex to the centroid. So that's the part of the segment that's supposed to be larger. So if that's 8, that's supposed to be twice as big as the other part. So this other part must be 4, which means that when we put it together, the total is 12. This next example says, imagine that Z to A is 9. So again, we've got vertex to centroid, so that's the longer part. That means this shorter part would be half of that, or 4.5. So the total would be 13.5 for ZC. Now the way that I think about this, centroid sounds like it's from outer space. It sounds like an asteroid or something of that nature. So I'm going to think centroid has the weirdest rule. Most of our other pieces have congruencies. This is the one that has 2/3 and 1/3. So with that, we've got 3 different examples here. These are all totally separate. So I'm going to number them as 1, 2, and 3. So looking at number 1, I know B to D is 4x plus 5, and the total, B to F, is 9x. So labeling what I know, I've got 4x plus 5 and 9x. Since I know from the vertex to the centroid that's supposed to be the bigger part, so if I take that and cut it in half, that means that this part should be 2x plus 2.5. Again, the reason for that is from the vertex to the centroid is twice as large as the centroid to the midpoint. Therefore, when I put all of that together, 4x plus 5 plus 2x plus 2.5 should equal 9x. I'm going to combine my like terms here, so I've got 6x plus 7.5. I'm going to subtract that 6x. So x is 2.5. Now, all 3 of these examples are going to give me slightly different information. I would recommend, however, that you try the second and third one on your own, just to see what you can do, and then unpause the video to check. I am, however, going to erase what's up here so far, and then we're going to go from there. So, looking at number 2, in this case, I know that G to D is 2x minus 8. Now remember that that's the smaller part because it's the midpoint to the centroid. And then G to C is 3x plus 3. So if I take that 2x minus 8 and I double it, 4x minus 16 would be the size of the other part of the median. So put together, 2x minus 8 plus 4x minus 16 should equal 3x plus 3. Altogether, I have 6x minus 24 equals 3x plus 3. So my x value should come out to be 9. Again, I'm going to erase what's up here to make space for number 3, so pause if you need to. So for number 3, we know that a to d is 5x. That's the larger part of that median. And then d to e is 3x minus 2. So remember that that larger part is larger by a factor of 2. So if 5x is twice as big, then I need to double the 3x minus 2. So when I solve this, I end up with an x value of 4. All of these are different types of questions that you could see using the median and the centroid. So think about that. The centroid is the one with the weird rule. It's got one part that's double the size of the other part. So with that being said, we are going to look at a quadratic here, and I have already said in class it is very probable that you are going to have some factoring on this test, simply because we have seen it on several examples in our notes. So make sure that you are comfortable with that lesson from Module 1A. If you've forgotten how to factor, make sure you go back and rewatch that video and make sure that you're ready for that part of the test. Typically our harder questions are worth more points, so you want to be sure you're ready. So this says b to p is x plus 4, and the whole thing is x squared minus 1. So looking at that, I know the larger part of that median. So I'm going to cut that in half to say half of x plus 2 would be this part here at the bottom. So altogether, x plus 4 plus half an x plus 2 should equal x squared minus 1. I'm going to combine my like terms. And then because I have a quadratic, I'm going to set everything equal to 0. Now, I don't know about you, but I don't want to try to find two numbers that add to negative 1.5. So what I'm going to do is I'm going to multiply everything up here by 2, since this is a half, so that it'll get rid of that decimal for me. The unfortunate part of that is that's going to make my a value not be 1 anymore. However, hopefully it'll make my factoring process a little bit easier. So I need two numbers that multiply to negative 28 that add to negative 3. So with that, I've got 4 and 7, and I need the 7 to be negative so that it adds to that negative 3. Remember that we cannot use the shortcut here because our a value, or our number in front of the x squared, is not 1. So what I'm going to do instead is rewrite the middle term. So I'm going to keep the first term the same, keep the last term the same, but instead of negative 3x, I'm going to say negative 7x plus 4x. The reason I can do that, if I were to put them back together, they go right back to negative 3x. Then we're going to factor by grouping. We're going to group the first two terms and the last two terms. So the first two terms have an x in common. The second grouping leads off with a positive, so I've got to factor out something positive. A 2 will go into both of those. And remember, our handy check-in here is that these two things should match. Since they do, I know I'm on a good path, so I'm going to bring that common factor of 2x minus 7 to the front, and then x plus 2 is my other factor. Now at this point, I am still looking for the value of x, so I want to make sure that I now take both of those factors and set them equal to 0. So 2x minus 7 could equal 0, or x plus 2 that equals 0. And that will give me my two solutions to this problem. So I either have 3.5 or -2. Now I want to make sure that both of those answers make sense in the context of the problem. So -2, if I were to plug that in to all three of these locations, right here, -2 squared minus 1, that's still 4 minus 1, that's 3, so that's okay. -2 plus 4 is still a +2, so that's okay. Half of -2 plus 2, so that's -1 plus 2, that is still 3. So, that should be, so we've got -1 plus 2, so that should be 1. So all of those are still positive distances. So even though we end up with a negative value here, it's still a valid answer because it doesn't make our distances negative. So both of those are completely valid solutions. So in the figure it says C is the centroid. If I know that G to F is 12x squared plus 6y, write an expression that represents CF. So remember that an expression is going to have variables in it. So think expression x, right? So we're going to have variables somewhere in this. So we're not looking to actually solve and see how long this is. We just want to write an expression that represents the size. So if I know the whole thing, then I know that CF, that's this bigger part here, represents 2/3 of the 12x squared plus 6y. What I do want to do here is I do want to simplify that as much as I can. So I am going to distribute that 2/3. So 2 divided by 3 times 12 is 8. And 2 divided by 3 times 6 is 4. So my expression would be 8x squared plus 4y. CG is the smaller part here, so that's 1/3 of the 12x squared plus 6y. So 1/3 of 12 is 4, and 1/3 of 6 is 2. So we've got 4x squared plus 2y. To double check our work here, if we were to put those right back together, these two equations here, or expressions rather, they will go right back to that 12x squared plus 6y. Oops, sorry, one ahead. So with this, we are not going to worry too much about finding a whole lot of these points on a graph. However, it is totally possible for us to find a midpoint and connect that to the vertex for all of these different points. So it is possible that you could see a question on a homework that asks you to find the centroid on a graph. So just be aware that in order to do that, you need to find the midpoint of the side and connect it to the vertex. Find the midpoint of the side, connect it to a vertex, and so on. For sake of time, I'm going to move us forward. Now we already talked about altitudes in the last video, but just a reminder here, it's a perpendicular segment from the vertex to the line containing the opposite side. The point of concurrency for altitudes is called the orthocenter. It can be in, on, or outside of the figure, depending on what type of triangle. So this last little bit here says, is MN a median, an altitude, a perpendicular bisector, or an angle bisector, or none of the above? So looking at this first one, we've got a vertex that's being cut in half. So this is going to be an angle bisector. For this one, we've got a vertex connected to a midpoint. So that's a median. And last but not least, we have a vertex connected to the opposite side in a perpendicular manner. So that is an altitude. It's not a perpendicular bisector because I don't know that these two parts are equal. So it says find a median in triangle STU. So we're looking at the whole picture right now, and we want to find something that connects a midpoint to a vertex. So that's going to be segment SB is our median within the whole triangle. The next part says find an altitude within the whole triangle. So an altitude connects a vertex to the opposite side in a perpendicular manner. So UA is an altitude. Then it wants a median within only SBU. So now we're only looking at this triangle, and we want a vertex connected to a midpoint. So B connected to C would be our median. Last but not least, we're looking even smaller at CBU, and we need an altitude. So a vertex to the opposite side perpendicularly, that would be UD. So this wants us to find the orthocenter of each triangle. So remember that that comes from the altitudes. So I want to find all of the altitudes within these pictures and see where they meet. So I've got one here and one here, and they meet at H. So H must be my orthocenter. Same thing here and here. So Y must be my orthocenter. Again, guys, memorization here is going to be key. So I want to be able to immediately associate the word orthocenter with the word altitudes, medians with centroids, perpendicular bisectors with circumcenters, and incenters with my angle bisectors. This one we did in our notes yesterday as well as this one here. So at this time you are free to go ahead and begin your practice for the day. If you have any questions, please feel free to reach out via email. Have a great day.